so the next piece is going to be to calibrate the volume of this cone. So what I'm going to do is I'm going to zero this guy out. I'm going to get the weight of this thing full. I think it's called like a bucket or something random in the procedure. It needs to be the first time I taught this class. It's the bottle, cone, and sand weight Pt4. So I have 10.853 pounds. Now what I'm going to do is I'm going to put it on. I'm going to put it on the plate. This is the plate on a flat surface. Make sure it's set in there nice and evenly. And I'm going to open it up. All the way open. The sand is now freely flowing from there to the base, and it's going to fill all the way up of the cone. My goal is to wait for it to fill all the way up to the surface, or sorry, to the very top of the cone. I'm going to turn it off, and we're going to find that exact measurement. And what's going to help us is the tear weight of what that cone is. When I go out and I do it in the field or the strata parking lot. Okay, so possible. Boop. All right, so I believe that this thing has stopped displacing sand. So what I'm going to do now is I'm going to close my mount, pick that up. I'm going to try not to make too much of a mess of that. And I'm going to get my new weight of how much came out. So, on my paper. And I went from 10.853 to 7.09. 7.709, excuse me. 7.709. Alright, so then you guys are going to find the weight to fill a sand cone. That is W3. And the next step is to refill this, get a new mass, and new first mass anyway. So I'm going to refill it. I'm going to get this W6 before use from the field, and then we're going to go outside and run the sand cone. Awesome.
Nope.
All right, so I put a little bit of sand back into this thing. So now my weight W6 is going to be 10.528. So now we're going to go out in the field and do one more test. Awesome. So one thing that I forgot that we're going to need is the weight of the gallon can. That's what I was trying to remember. That kind of confused me the first time. All this is the bucket or the container that I'm going to put my soil sample in that I dig out from underneath of the plate. So I'm just going to use that pan if I was actually in the field running this test. For example, if I was out at the airport right now, because the FAA regulations do require one, I would have something that would have a lid on it, so that way I can retain the moisture in the sample. But since I'm just going outside, I'm not going to gravel. That's 0.755 pounds. And then I'm going to take all this and go out to the field. Pause.
Go.
Okay, so welcome to the back strata parking lot. I found a spot here that's nice and flat. So what I'm going to do is I'm going to put my plate down. The bigger ones are a lot easier, they're even heavier where you can do this, but I'm going to try and stand on it and see how awkward I can make this thing. And what I'm going to do is I'm going to dig my hole. See how much of this stuff I can get in there. The deeper the hole, the more accurate this whole thing is going to be. I'm going to try keep doing this, not to spill. And I'll actually probably just pause this video until I can get a good hole dug. Alright, so one issue that I'm having here that if I was actually out on a site running this, I wouldn't have is I hit a tree root from a wonderful tree. So I'm not going to worry too much about it. We're just going to realize that it's not ideal. So now what I'm going to do is, now that I have my not very deep hole, again, the deeper it is, the more accuracy you're going to have. This is not very deep at all. Typically, and I'll show you guys the bigger sand cones we use, but the bigger the sand cone, the bigger the hole, the more like cone shape it is, the better it's going to be. So what I'm going to do is get the rest of this loose material out of there. That's one thing I forgot. Because you want to get all the loose material out. Let me see if I can't get a lot of that. loose material out, then I'll get all the excess from this plate into my bowl. And that is probably about as good as I'm going to get. I'm going to take this guy right there, and without shaking it, without disturbing it, without doing anything, I'm going to open that up, and now we're just going to run. And we're just going to wait for it to stop draining sand. Probably pause it right now. All right, so it stopped moving, so I'm going to turn this off, pick it up. There's all my extra sand. I'm just going to leave all this there, and we're going to go drag the rest of this back inside. So we'll see you guys back inside. All right. So here is the sample that I pulled from outside. That weight is going to go. Where's that weight going? Weight a gallon and moist soil. So that is 2.231 pounds. Take this off. I'm going to save this for later because that's going to go in an oven. And that oven's on. That's going to go in an oven or on the burner. We'll cook it out. We'll get the dry weight so we get a moisture content of that. And the next piece is we're going to weigh this guy. Figure that out. And the weight of my gallon jug is 5.643. So then you guys are going to calculate the volume of the hole with this calculation right here, the density of the sand that you calculated from up here. You guys get the, I'll give you guys this weight right here, which is going to be your dry plus your container. And then you guys will calculate the rest of this. So that should be that for the sand cone. Good. So one thing that I'm going to show you guys that I couldn't do if we were in the actual lab is this nuclear densometer. So this thing is radioactive. This is what we use in the field. This is what everybody uses in the field. It basically replaces the sand cone. Now, like I was saying earlier, the sand cone is that mechanical method that's tried and true. It's hard to mess up. You know, it just needs to be calibrated physically. This one is, you know, it's a little bit more, I guess, in depth, a little more electronic. So, but I figured I'd come out here to where we did the sand cone and shoot like a 2-inch shot or a 4-inch shot. It'll be basically the same thing. I'll show you guys how to do it. The reason I'm wearing my vest right now is because I have my my nuke badge on it. I figured if I was doing something on film, I might as well not do anything illegal. So I do need to have this badge on me, and it basically is one of those badges that collects radioactivity. We send it in every however long it is to get it tested to see if I have absorbed too much radiation. With that being said, I'm more likely to get cancer from the sun than I am from that box. But like I said, I'm going to run a 2-inch test. If you guys were out doing like a 6-inch base layer, I'd be out there on your site shooting a 6-inch shot. But that hole is about 2 inches, so just to compare notes, this is not anything that you need to do for a lab. I thought about giving you guys the ITD form that I would be using. I figured it's just not worth it in this scenario. So what I'm going to do is I'm going to drive a stake in a flat spot. I'm going to try and flatten the spot down a little bit. I'll take a 2-inch and a 4-inch shot just to see where it's at. So I drove it there, 4 inches. And pull that out. Change the time on this to 15 seconds. Change my dip. I'm going to do the 4-inch shot first. I'm going to run that test, and I step back away from it because not only can I read the moisture in my body, it's also a safety thing. So I run that test. Again, they're 15 seconds long, and as soon as that beeps, just like that, I can walk back over, pull this handle back up, and according to this, my wet density is 90.5 pounds per cubic foot. My dry density is 83.8, and my moisture content is 8.0. Now, the reason I'll bet that this is going to be a lot different from the sand cone is because the sand cone wasn't done. I guess I'm not going to say it wasn't done correctly because it was for my scenario, but for example, I hit a tree root. You know, because there's a lot of organics in here, things might be slightly different. Because of a lot of different reasons, it probably won't line up well. Now, if we were to go out and do it on a real road base, then we basically use the sand cone as a correction factor, and they are a lot more consistent. For example, between not this gauge, one of our other ones, and a sand cone, it was about a pound correction. So this guy was about a pound heavier than this. And that's a pound per cubic foot density. So that difference isn't a whole lot. I'll try a 2-inch shot just because we can. We're here. And it's still set 4, so let's change that depth. 2-inch shot just because we can. That's still 8.8% moisture. That's 170 point now. 170, that's 71 pounds per cubic on the dry and 77 pounds wet density. Now the difference between those two shots is one was at 2 inches, one was at 4 inches. This surface material is super loose, but as soon as I get kind of below that 2-inch mark, that's when it hardens up. So it's not surprising that the density down there is, you know, higher than it is on top. What that means for you guys as construction management guys is to tell your inspectors the right depth. Because if you tell me the wrong depth, if you have 6 inches of material and I come in and I shoot a 10-inch shot, that means I'm in the material that, you know, was maybe native or a different type of material. So I could get a higher or lower density depending on what that is. If you're putting a 6-inch or 8-inch or 12-inch road base over clay, and I shoot a 10-inch shot that's supposed to be, you know, 8 or 10 inches, I'm going to get a bad value. On the other side of that coin, if, you know, you're on a, you know, whatever's blower is a lot harder, then I can get a much higher density, which isn't the end of the world, but it's going to make me kind of scratch my head there if it's unrealistically high. So that's the Newt gauge. And at this point, if you're still actually watching this whole thing, send me an email and I'll give you a couple extra credit points on this lab because you're actually watching when I know you don't have to. All right, good. All right, so like I was saying earlier as well, the bigger the sand cone, the easier it is. This is our bigger sand cone. Obviously, I can make a much bigger hole into that. I'd actually use a shovel. I don't know where the plate is for this one. I'm sure it's still in our storage. The last time I had this thing out, I was calibrating it, and I don't think I ever actually used it. But just for you guys, you know, show and tell, this is a bigger sand cone that is significantly more accurate if we were to use it, but because it's a lot more material, I didn't want it. So that's all for this.